Hey folks, Polar Unit Learning Guide. Problem number one, want to find an equivalent expression for each of the following: r squared, x, y, tan theta, and theta, based off this little right triangle diagram here. Now real quick, essentially what we're saying is we're talking about this Cartesian point right there, x comma y. And what we're going to do is we're going to look at how we can express that same point in a different way. We're going to express it using polar notation, r comma theta. And so in order to do that, we need to come up with some relationships between x and y and r and theta. So first one, r squared, notice that since this is a right triangle, it must follow the Pythagorean theorem, which says r squared, the hypotenuse squared, equals one leg squared plus the other leg squared. So r squared equals x squared plus y squared. There's one of them. What else can we do? Well, we want to come up with an expression for x in terms of r and theta, and then another expression for y in terms of r and theta. So to do that, we're going to need to use some trig. So let's use some SOHCAHTOA here. SOHCAHTOA. So is saying that the sine of theta is equal to the opposite side, which is y, divided by the hypotenuse, which is r. And if we wanted to solve this for y, we could multiply the r up and get r sine theta equals y. So there's a nice relationship there that we can use. Similarly, from the ka, we can say that the cosine of theta equals the adjacent side, which is x, divided by the hypotenuse, which is r. And we can move that r up by multiplying it, just like we did the other one, to get r times the cosine of theta equals x. So there is two of our three relationships that we're going to use. Next one, let's go ahead and use tangent, TOA. So tangent of theta equals the opposite side from theta, which is y, divided by the adjacent side, which is x. And so tan of theta equals y over x. Y over x, kind of like rise over run, kind of like tangent is slope, kind of like how we think about it on the unit circle. So that's a good one. And then the last one, what about theta? Well, if we have tangent of theta equals y over x, and we apply the inverse tangent to both sides, the arctangent to both sides, we get theta equals the tan inverse of y over x. And so we have created these five relationships, which we will use to complete the rest of the problems.